Welcome to my lecture on shear strength parameters of soils. As we have seen in the previous lecture, so shear strength parameters are nothing but C and phi. So tau is entirely influenced by C and phi. So I gave an equation tau equals to C plus sigma tan phi as denoted by F as well. And Mohr Coulomb equation, combinedly Mohr Coulomb work equation, sigma 1 equals to sigma 3 tan square alpha plus 2c tan alpha. So this is given by Coulomb and this is given by Bell equation. Actually this equation has formed by combined work of Mohr Coulomb, but this equation is derived by Bell. So failure envelope equation of Coulomb is this. So this is our major concern as I explained the applications of foundation failure, slope failure and retaining wall failure. So this is an like mantram. So this is going to be an equation playing role to design. So tau is an our concern. So in order to find tau, we need to find C as well as phi. So we can find tau f. So we can start our design works. So first, how to find this C and phi? So this is what determination of shear strength parameters we are going to see in this lectures. So lab test. So we have some laboratory tests. For this laboratory tests, you need to collect undisturbed soil samples. How to collect undisturbed soil samples? So by the way, you need to going to design some foundation. So you need to collect some soil samples below certain depth. So this certain depth is foundation depth. So below which you have to collect undisturbed soil samples, because once you collecting the sample, if your structure has disturbed, so that phi value definitely going to be disturbed. So the whatever the thing you are going to find in the laboratory test will not refer your field. So that is why your result, that result will not reliable, and the design which you are going to do will not be proper anyway. So you have to collect undisturbed soil sample and need to be tested in the laboratory. So what are the tests we have? Let me explain this one by one. Direct shear test, triaxial shear test, unconfined compression test and vane shear test. So this direct shear test, DST. Direct shear test is nothing but it is given by Coulomb, and this triaxial test is developed by Terzaghi and Casagrande. So this is Coulomb. So direct shear test. So we are taking this is going to be loaded by normal stress, and you are giving some shear force directly in horizontal plane. So this bottom portion is fixed. So this bottom portion is fixed, and this top portion is going to be moved. So the force is applied directly. That is why it get the name of direct shear test. So it has usually it has an 6 cm by 6 cm plan area, and the soil sample will have an depth of 2 cm. The sample is collected, let us say whatever may be. So collected and loaded, and the frictional force applied. So it is at different trials, you are say N1, N2, N3, we are doing it, and the frictional force, shear force is going to be in test. So this is what exactly Coulomb has done. We have modernized the equipment furtherly. So you get, if you done cohesionless soil, you get value for phi value. It is an C phi soil, you get both C as well as phi value. If it is an pure clay, what you are going to get is nothing but C value only. This is nothing but a direct shear test, as I explained in my previous lecture. Let us see triaxial test. It is a very major part. How this get name of triaxial shear test? By the way, whereas here we collected a sample like this. So here I am going to collect a cylindrical sample. Actually this is a cylindrical sample, and I am going to place it in a triaxial cell like this. So there is an outlet. So this place also an inlet. So this is will be placed over a platform. So this is soil over a platform. It is placed. Please look at this very carefully. So this is an setup. So it is an inlet and outlet, water inlet and outlet, inlet water or outlet. So there is an so here also there is a platform and it is connected like this. It will be connected like this. So what happens once the water is going inside? So we have a constant pressure system. We have some knobs like this. It can be rotated. So once you rotate the knob, so you get the pointer moving. So which means in terms of once the water is filling it. So once after filling the water, so this soil specimen has to be perfectly protected by permeable membrane. Once you filling the water inside, so that water cannot be permeated through the soil pores. So because it is perfectly protected by rubber membrane. So once the water is allowed to fill this chamber called a shell, once it is filled, and you can adjust just a knob in this constant pressure measurement system. So the pressure inside is controlled by the way which you are applying. So 10 kPa, 20 kPa, 30 kPa is an kilonewton per meter square. The pressure, fluid pressure which you have applied, 40 kPa, 50 kPa, like 60 kPa. So this is how we are going to input the pressure. That pressure is nothing but sigma 3 confining pressure or lateral pressure. Confining pressure and lateral pressure. So during this pressure application, so let us see, this is a confining pressure application. Consolidation is going to happen. So this is a confining pressure alone application. So the sample is loaded in all the direction. That pressure is nothing but sigma 3. So here also sigma 3. So in every direction it is sigma 3 which you have applied. So now the water present in this, the pore water pressure is going to be developed. The pore water pressure is going to be developed. So to measure the pore water pressure developed because of the compression, so there is a soil sample, it is equal isotropic consolidation. So the pressure is applied in all the direction is going to compress your soil sample, but there is an water inside this soil. So that water doesn't allow the soil to be compressed because it develops pore water pressure in the opposite direction. This is how the pore water pressure develops. So in order to find the magnitude of this pore water pressure, so we have some tubes connected both top and bottom. So this is connected with Bishop's pore pressure measurement system. So it is a wooden frame. So this Bishop's pore pressure instrument measurement system in a wooden frame is going to be, so this is connected, so with here. So once you are giving, so this isotropic consolidation happens, the pore water pressure developed, what is the value of this pore water pressure developed can be found through this Bishop's pore water pressure measurement system. So the consolidation is going to be happen. So this is what consolidation stage. We have another stage, shear failure stage. So during this isotropic consolidation process, so shear failure may not be occur. Once if you are, so this is what be like this. So you are applying load through proving ring or load cell. If you are applying load, what is going to be happen? So this is the thing always already there, and you are slowly increasing sigma 1. Actually it is deviating stress. So this is a load that you are applying. So here also load will be generated. So sigma d, it is going to be deviate the sample. So we call it as an deviating stress. So confining, apart from this confining pressure also there. This is an deviating stress applied by a proving ring concept. So deviating stress subjected to this vertical direction only, confining pressure as well as that. So this is deviating pressure. going to compress the soil. So we say it is an deviating stress. This sigma 3 will be directly the value taken from this constant pressure measurement system, but the sigma d is nothing but we apply in terms of proving ring, so we get load. So load divided by this area is going to be will be the sigma d value, and you are slowly increasing it in order to fail the sample. So that is why I have wrote it on shear failure stage. So we are slowly increasing the proving ring, loading. So sigma d is increasing. Once the sample is failed, maybe failing like this, so which forms alpha. So this is what the theory I have explained in my previous lecture. So here, so this can be written also in terms of sigma 1. Sigma 1 equals to sigma 3 plus sigma d. Here also sigma 1, but here it is not sigma 1, it is sigma 3. We are not applying any deviating stress in the lateral direction. So sigma 1 is the sigma d plus sigma 3. So this may be 20 kPa and this may be on 40 kPa. So combinedly it is 40 kPa is in sigma 1 value at which your specimen fails, making an angle of alpha. So last time I have explained you that pore pressure. So this is an Bell's equation, sigma 3 tan square alpha plus 2c tan alpha. It is an Bell's equation in terms of total stresses. As I told, if you found this pore water pressure developing inside the soil specimen, let us say it is u. Once you found the u, so sigma 1 dash equals to sigma 1 minus u we get. So this is so the equation can be written in terms of effective stresses, sigma 3 tan square alpha plus 2c tan alpha in terms of dashes everywhere. So in order to get this sigma 1 dashes, you need to find what is the pore water pressure developed inside the soil specimen. So u need to be found. So when this Bishop's pore pressure measurement system allowed to find the u, you can find the u and you can substitute this sigma 1 and sigma 3, you get. So sigma 1 dash is sigma 1 minus u, sigma 3 dash equals to sigma 3 minus u. This is the value, you can get it. This pore pressure also can be theoretically measured as given by Skempton. So if you have not this Bishop's pore pressure measurement system, you can compute what is the pore water pressure developed during the test using just as Skempton's theoretical measurement. No need to connect this Bishop's pore measurement. He has some idea. So Skempton pore pressure theoretical measurement. So del u is going to be the value of b times del sigma 3 plus ab times del sigma d. So b is okay as it is, and ab del sigma d is in del sigma 1 minus del sigma 3 can be written. So b can be taken commonly outside plus a into del sigma 1 del sigma 3 will be the remaining factors. So here a and b are pore pressure parameters given by Skempton. So Skempton, also it is known as Skempton's pore pressure parameters. So whereas your b dependent on saturation. So b equals to 1 when degree of saturation S equals to 100%, which means when your sample, when your soil sample has fully watered, what is the pressure you are applied, equivalent pressure will be oppositely developed. So when b equals to 1, so during the isotrophic consolidation, when b equals to 1, so the pore water pressure developed excessively will be the same of the pressure which you have applied. So that is b. So when b is less than 1, degree of saturation less than 100%. So it depends. Whereas the A talks about over consolidation ratio. What is over consolidation ratio? Now when your soil over consolidation ratio in this sigma PC, it is a, so recall your consolidation process. Pre-consolidation pressure, if your soil has, in its history, soil has faced 100 kPa, which means 100 kPa it has already faced. Presently you are applying just 80 kPa, so this is known as over consolidation pressure, which means your soil has already faced so much pressure already, but you are applying pressure lesser than that only, so it won't fail. So which means like that, by the way. So over consolidation OCR value, say OCR value is equal to be 4, so your A is going to be 0. It is just around 3.724 around this value, so this A is going to be 0. OCR is greater than 4, it is overly consolidated, it is already consolidated. Once you apply the load in all the direction, it won't compress anyway, because it is already compressed. If you apply more load, it won't compress, instead the volume is going to be increases. Because of this volume increase, so there will be suction. So wherever the suction takes place, pore water pressure will not be positive, it is going to be negative. So greater than 4, it is going to be negative. So A value is positive when OCR is less than 4. About it is 4, it is 0, it is negative when greater than 4. To explain this clearly, so your soil sample is well compressed, already well compressed, and you are applying load in all the direction. This is going, during the fail, the volume is going to be increases. Because of this particle displacements, there is going to be empty spaces, so water is trying to outside to inside, because there is a tube, so water can come. So outside to inside movement is in suction, so that is why it is negative. Whereas your soil is very loose, you are applying load in the other direction, it is going to be compressed anyway. So this is an initial volume V0, this is an final volume. So the volume is going compressed and fails. So here the case is different, here the case is different. So that is why there is a possibility of negative pore water pressure also. You should understand this. So negative pressure also. So fine. So this is a negative pore water pressure. So if you apply this minus value here, negative value here, so there is a possibility of negative pore water pressure developing. So this is a major concept. Whereas it occurs only in over consolidation soil, overly consolidated soil, which is entirely dependent on pre-consolidation pressure. So learn the importance of pre-consolidation pressure here. So in the same triaxial test, we can do the test under different drainage conditions. So we have different tests. This is shortly known as UU test, unconsolidated undrained test, consolidated undrained test, CU test, consolidated drain test, CD. So to explain this, so this is an soil sample. So this is pore water measurement tube. So during the, so I can split this 2 times. So this is an consolidation process, only sigma 3, it is consolidation process. So once you are allowing the consolidation process, then you can start the shear failure. So this is shear stage as explained earlier. So I can split this 2. So this is unconsolidated undrained refers. So this is an pore water pressure valve. So we have a open close valve. So when sigma 3 is applied, whatever may be sigma 3 is applied, and we are applying a sigma d. So during the application of sigma 3 in all the direction, this pore water pressure valve is closed, which means you are not allowing the water to go out of the system. By the way, it does not get compressed anyway. So once the water is going away, this soil is going to be compressed. If this valve is closed, so the water will not go out. By the way, the soil will not be get consolidated. So that represents unconsolidated, undrained. So during the shear stage also, during the application of sigma d also, this valve is remain closed. So represents undrained during the shear stage. So this is shear stage, this is consolidation. So both the consolidation and shear stages, the valve is remain closed. Refers unconsolidated, undrained. So why we have different drainage condition tests? It has different meanings. So by the way, you are going to construct any foundation. So you are going to keep increasing the load. So let us take this as an deviate axis. The soil has already subjected to under pressure, you are slowly increase the load. For this sigma 3 pressure, the soil has not consolidated yet. Maybe. By the way, you are increasing the sigma d deviatic stress also. The water will not move rapidly. So it takes time. Consolidation process may take years and years, 100 years. So by the way, during the confining pressure also it is not consolidated, and during the application of building load also it is not consolidated. So this is the thing you have to do under the triaxial test. So the wall should be remain closed. So this is quick test. You get value very rapidly. Whereas your consolidated undrained test, during the consolidation process you are opening the wall, so you are allowing the water to flow out so that it gets consolidated, and during the shear stage you are going to once start loading the sigma d, you have to close the valve, then only you have to start. So during the shear stage it is undrained. So this is rapid test. Why it is rapid test? For the consolidation process you should know the soil is whether consolidated or not. What we do, so we open this it is, and we are connecting it to volume change measurement apparatus. It is alone cost 1.5 lakh. So this volume change measurement apparatus or burette. So instead of going this costliest apparatus, we have some burette setup. In this burette setup, the volume change is going to be measured, which means del V. Let us say this is initial volume V. Once you apply this consolidation and confining pressure, the valve is open, so the water is going to be allowed go out. So the volume is get reduced of this much del V. So the final volume will be V minus del V. In case for the OCR value, this is going to be V plus del V. So volume is going to be increases if it is an overly consolidated soil, as explained. So negative pore water pressure may develop. We are allowing it to consolidation, and once you are applying shear load, the valve is closed. This consolidation process may takes 3 days. So this consolidation process alone may take 3 days to get compressed. So then only you can start undrained shear loading type. So this is like it takes too much time for this consolidation, but undrained condition will be tested very quickly. So that is why it has the name of rapid test. So we have another test, consolidated drained. So both the consolidation process, the valve is open, and here also valve is open. So it is drainage valve. So drainage valve open, open. So drainage valve open, close. The drainage valve closed in the both the stages. So it may be also asked in any multiple choice questions. So drainage valve, it is open, close. And drainage valve, it is will be closed. So this is how we can do tests under different drainage conditions. So by the way, how to get C and phi, sir? How to get C and phi in this case? So you can draw a circle for the one sample collected. So we need to collect two samples, sample 1 of sample 2 representing the same structure, undisturbed sample. For the sample 1, 30 kPa and 100 kPa the value we get. For the sample 2, you get different values, 60 and 150. So this can be increases by just adjusting the knob. The constant pressure, confining pressure can be increased. Once you get this two circles only, you can get this C value as well as phi value if you are done this under different drainage conditions. So for as explained, it is in foundation case. So this has separate meaning and this has separate meaning has to be done. So you get different curves like this. You finally you get C dash, C and phi. Once you done, if you get the pore water pressure means del U. So this sigma 1 dash sigma 3 dash tan square alpha plus 2C tan alpha in terms of effective pressure. So this is what the concepts related with triaxial shear test, unconfined compression test. So by the way, unconfined compression test. So here it is in a special form of another form or special form of let us say triaxial shear test. So in this case you are also going to take a undisturbed soil specimen in a cylindrical way. So sigma 3 will not be that, you are not going to apply any sigma 3 value. So you are just going to give deviating stress. So here deviating stress equals to sigma n, and you are going to apply compressive load. So under this compression this is going to be failed. So we can directly write the equation sigma 1 equals to, so pore water pressure measurements cannot be done here, so you cannot know. So because it is not confined in here, it is not confined through any permeable membrane, you are just collecting a soil, and it is specially suitable for clay only. So then only you can collect this kind of an undisturbed sample like this. You cannot prefer sand for this test, but you can prefer, so the soil, what is the soil it is? So it may be a sea soil or phi soil or sea and phi soil, because it is in membrane. So in this membrane you can fill sand as well, so you can form a specimen like this. You can take sea soil as well, you can take sea phi soil as well, but here it is not going to be there is no membrane here, there is no membrane here. It is a simple test setup. You collected a cylindrical sample like this, and you are going to be loaded like this. So this is nothing but sigma 1. So whereas sigma confining pressure is absent, that is why it gets unconfined compression test. So we have equation sigma 3 tan square alpha plus 2c tan alpha, whereas as told sigma 3 is going to be 0, so this part won't be there. So sigma 1 equals to 2c tan alpha. So alpha is nothing but failure plane, numerically it is 45 degree plus 5 by 2. Let us say this is a clay sample. For the saturated clay sample, phi is going to be 0. So phi is going to be 0, alpha equals to 45 degree only. So sigma 1 equals to 2 times c tan 45 degree plus 0, so remains tan 45 degree. So tan 45 degree is 1, so sigma 1 equals to 2 times the c, so c equals to sigma 1 by 2. So the cohesion value which you have tested in the laboratory is nothing but what is the compressive load you have applied in terms of stress. Sigma 1 by 2 is an cohesion. So what is sigma 1 here? If we have applied, sigma 1 is nothing but load by area. Anyhow, during the application of load, your soil may be like to bulge like this. So this is an sigma 1. So during the failure, the area, initial area will not, cannot be applied because it has bulged. So you need to correct it, AC. So AC is nothing but initial area divided by 1 minus epsilon. It is a small derivation. So in triaxial test also you have to do like this only for to compute the sigma d value. So area is V plus, in case of in a triaxial, divided by L minus del L in triaxial test. So there is an volume increases chance, that is why plus V I have written. So here area equals to V minus del V divided by volume is going to be reduced only, L minus del L. So this area corrected is taking a form finally A naught divided by 1 minus epsilon. Epsilon is del L divided by L, that is an initial area. Usually the area is described, so dia equals to, length equals to 2 times dia. So this is what dia d. So length is always taken like this. So length has to be 2 times dia. It is in ratio. For it may 38 mm of dia, 76 is going to be the length. That is how you have to prepare sample for the test. So initially it is in length is 76 mm. So at the time of failure, so it is came down to 70 mm, let us say. So what is the change? 6 mm. So 76 by 6. So you get in terms of percentage strain. So that percentage strain has to be substituted in terms of decimal only. Substitute this value in decimal here. AC equals to A naught divided by, it is an initial area. So initial area with help of 38 pi d square by 4 is an initial area A naught. Substitute this value here. So area corrected will be it here. So we have to substitute this area corrected for the failure load at the time of failure, it is 11 kg, say. So 11 kg divided by this corrected area is going to be the sigma m value. So the cohesion of the sample is sigma 1 by 2. Very simple test. So it is not preferable for phi, it is not preferable. C and phi, how it works for C and phi? How it works for C and phi? So it has some meaning here. If you are taking this C5 value, C5 soil, if your sample has failed, say alpha, so this alpha can be measured in a possible way if you are measuring this alpha in terms of 60 degree. So this has some graphical procedures only, you cannot go for this numerical values. So alpha has 60 degree. If you are during the test you have measured alpha as 60 degree, so alpha is 45 degree plus 5 by 2, so 60 degree equals to just 45 plus 5 by 2, so it is 15. So 5 by 2 equals to 15 degree, so 5 will be 30 degree. It is possible to measure angle of internal friction in UCC also once you get a clear failure of with the plane making some angle with the horizontal plane, you get value. So also it is then possible to find phi value in UCC test. So it is an last test, vein shear test. So we have a vein like this, vein in the sense blade is an synonym for vein. So this is an front view, this is front view, and this is top view, front view of veins. This is top view. So to give it, I was trying to give it in a three-dimensional way. This is how it will be there, veins. So there is a 3D view, this is what a 2D view. So this has vein height, and this is dia, this phi is dia D. So this is vein dia D. What we do, we are going to rotate this, and this, let us say this is in a borehole, this is inserted. So this is a vein portion immersed in the soil perfectly. When I am giving some load, so this is an lever arm distance Z, so I am twisting it, I am giving some twisting force. This is going to apply some twist, but the soil cohesion will not allow the vein to be twisted. So what is the force you are applying to be twisted will be exactly equal to the cohesion value. That is how this vein shear test has some meaning. So let us say torque applied, so torque applied, let us say T. So this is what torque applied. So let us, this is an force, say 2 Newton force. So here 2 Newton force, the total force is 4 Newton, or by the way Z equals to 1 meter. So 2 into 1 4 Newton, sorry 2 into 1 2 Newton plus 2 Newton, so it is 4 Newton is an 4 Newton meter. It is an torque which you have applied. So it is rotating, so the veins are rotating, and it is going to be shear the soil. So that is what the load which you have applied. So cohesion is an unit of kilonewton per meter square. So this is the load which you are applied. What is the area subjected to the shear? So the area subjected to here, so it is going to form like a cylindrical surface is going to be subjected to shear. So let us say this is an circumferential area, as well as this top circle has also subjected to some shear, as well as the bottom circle is subjected to some shear. So this is a circumferential surface area. So this is top forming a circle, bottom forming a circle. So whereas this tau is likely to be vary, it will not be vary here. So this torque is applied at the edges. So this torque applied at the edges will not be vary because R will not be changed. But both top and bottom, as explained here, so when the lever arm distance increases, so it is 2 meter by 4 meter, 2 meter into 2 Newton, it is converted into 4, totally it is going to be 8 Newton. So likewise this lever arm distance increases, the torque increases. By the way, so from this center point, so the force applied to the soil is comparatively lesser than this, and comparatively lesser than this. So likewise it is going to be, which means this is how shear will be applied in the soil. So both are positive. So the shear stress applied is going to be vary with respect to center to outer faces, but here it is won't be changed. So we are going to need some integration part here for a top circle, for bottom circle as well. So this total torque applied is going to be converted as, so T circumferential plus T bottom surface plus T top surface. So T circumferential is nothing but force into radius. So finally it gives forms tau equals to phi dh into d by 2, dia of veins d by 2. So T circumferential equals nothing but tau pi T square h divided by 2. But this, it is an integration part. T top and bottom, so let us consider bottom only first. So then multiply with, we get top as well. So you are going to need some integration part, that is I won't like to explain. This is tau h d cube divided by 6, then final derivative form. And when the veins are fully immersed, so veins are fully immersed, top circle is also going to be come. So finally the torque applied is going to be equal in the form of tau h d square h by 2 divided by d by 6. That is one major equation given by vein shear. So the torque applied, there is a value you know. So the torque applied, so h height of vein you know, dia of vein you know. So the value tau is going to be found through this end of the test. So here tau equals to, you know, C plus sigma n tan phi. By the way, you cannot measure sigma n tan phi at the borehole. So this test is not applicable for phi soil. Maybe C phi soil applicable, but you get value of tau is nothing but equals to C. Tau equals to C. It is an shear strength of value, shear strength of soil and C. So this is an soft sensitive clay only, soft sensitive clay soil only. This is going to be prepared, because you see this test you are going to need some cylindrical sample like this. When you are not able to collect this cylindrical sample because of this soft sensitiveness, so this is not preferable. You have to do vein shear test. So that is an advantage of this. So we have each different tests. So direct shear test, triaxial tear test, unconfined compression test, and vein shear test. Each test has its own limitation, advantages and disadvantages. So in this direct shear test, the major disadvantage is you are applying direct load in the horizontal plane. This horizontal plane may not be the weakest plane, but you are voluntarily applying the horizontal plane and you are collecting some results. So this results may be improper. So that is a limitation of this direct shear test. Triaxial shear test, under different drainage conditions you get value. This is more or less advanced, reliable values can be given. So this unconfined compression test you get only C value, sometimes phi value also possible. So vein shear test is applicable only. So soft sensitive clay which cannot be sampled in for the unconfined test, you can go for field vein shear tests. Thank you.